So hi, what's up? So welcome to Cognitive Lab again. Today we'll create a neural network library like keras, like TensorFlow, but not that high level. We can start it from low level and we can add the features, more features that we need from other projects, and we can create a neural network library from the scratch. If you do not know anything about anything, so you are right place. We can implement here all the code that needs for a neural network library from the basic, from the scratch. So how can you do that? So let's think what we can do. So before getting started, if you do not know what is neural network, so I will previously in my previous videos I will tell what is neural network. So hope you guys already familiar with that video. If you did not watch that video, then please go to the description, and in that description I give the link of the video, and just watch it and come here. Then we started to implement code. So if you do not know anything about anything, so just YouTube them and search. You have a ton of videos and just watch them, and then come back here. For the calculus, you go to 3 blue 1 brown, essence of calculus. And for linear algebra, you can go Khan Academy. And for back propagation, you also go 3 blue 1 brown, and then come here when you know all that things. And if you do not know what is neural network, you are confused by understanding, then just go my previous video here. There I will tell from the scratch how can you understand the neural network, what is a neural network. So let's get started. So we can create a neural network library. So the first question is getting why we need the neural network library for own, because already we have keras, we have TensorFlow that is very high level, and we can use it for any code, any project. Because of we cannot use some project, that if you have a specified project of your own, a big project, then you have many certain needs, like you want to copy the all weights and pass into another neural network, and then you can apply genetic algorithm, and then you can apply mutation, and you can fix your mutation rate, and based on a fitness rule you can cross over them and make child of neural network, child AI, child multi-agent. When you working with multi-agent reinforcement learning and many things, when you working with experience memory, relay memory, then you also need your own neural network library, because all that operation will be held in that library and that will pass to the neural network. So you have to need that own neural network library. So you have any project for that, so just create. So here we can implement all that code in very easy way. And in that situation I do not know how can I implement all these codes in Python. We can use here PyCharm, you can use Jupyter Notebook, anything you want. And we can use Python, you can use C++, because all the same code are same for that C++, but the syntax will be others, because C++ syntax like for loop we can do not try to increasing or anything. I++ we do not written here, but in C++ you have to increment that. So some certain syntax will be different from Python and C++, and all the other same construction function, that like in Python we have init function called in class, and in C++ we call that init function construction function. So hope you already familiar with that. If you do not know, just watch them and you can probably understand, because I will do not know what can I do now, but I will try. Okay, so we can start it by a simple, very simple diagram. Then when we can implement that code for that diagram, then we can do much more. Here one thing we remember, we can use matrices. What is matrix? The matrix is a number, a list of number, array. Here we can use numpy. Numpy is a pre-built library for many mathematical calculation, and you can use it. So we can use it for array, because we create a multi-dimensional matrix. What is matrix? If you do not know, just go in YouTube and what is matrix, you probably know. So some certain thing you have to know is what is the dot product of one matrix dot other matrix. Like matrix means these two horizontal line, and in that line we have some numbers 2 3 4 1 1 0 0 1 here 1 here 1, and this that horizontal line is represent the column of that matrix, and that vertical lines represent the row of the matrix. So this is the column, this is the matrix. When we increase the row, it will increase that. Now if you need the certain number from that matrix, from that block, then you can just simplify. It's a I into J matrix. Now I means the column and J means row. So if you need 3, so this is number 1 column and number 2 row. Now this is number 0 row. So we can in code you probably know that we can start it from 0, not 1. So don't be confused by that. We use 0. So here this is 0 column into row is 0 1. So 1 row. So if you can write that, we got this number by this is like w np.w array. We can, this is the w array. If you write like that w, and then in a box we can write like, okay, 1 minute, I know my drawing is too bad, so please try to understand, don't be panic. I can, so here you can see I can clean up all that because that is very nice. So hope you guys see that. So here I can write a matrix w. This is w matrix 1 2. Hope you guys enjoy. I am very bad on drawing, so try to understand and I can try to implement on that drawing. So this is 1 2 3 4, a matrix like that, to line, and in that line, in middle of that line, we can specify some numbers that it called matrix element. So this called row, this is the vertical line is called row, and the horizontal line called column. So this is w. If you do, like if you need the 2, we have to need number 2 element. So how can we get that? So we can write the matrix name, we can give a big box like this, and we can wrote the column number of that element. So here in first column, this is 1 column, this is 2 column, this is 3 column. So in first column, no, 0 1. So we have that in number 2 column. So we have to number 1 column, because in programming code we have to start it from 0. So this is number 1 column, and this is number 1 row, because 0 1, this is row 1. So column 1 row 1 we can write, and we can get the number 2. So if you do not know what is matrix, how can I represent a matrix, just go YouTube, just search what is that, and you can get a ton of videos. How can I implement all of this? So we can use np.array. That means that box and that list is converted into array, and array means a matrix. Okay, so let's start it. So now first we all see how can I implement all of that code for a simple structure. Then we can build for main structure, many nodes, and we can like that. So we can use matrices for that. So let's start it. I do not know now how can I implement that, but I can think. Pause the video whenever I think. So now let's begin. So now I can write a simple diagram. You can understand that. So there have in input layer we have 3 nodes. In hidden layer we have 1 layer hidden and 2 nodes in 1 hidden layer, and then we have an output layer and there is 1. So for the simplicity of this calculation, we have to take a simplified version of that neural network. So now how can we implement all these biases by code? Because we need a mathematical expression for all that weights, because we creating a library. So that a library can take any amount of input and calculate all that, and for that we need a equation or a formula that can take all that inputs and calculate according to our operation. So how can we take all that weights? How can I represent all that weights connected to corresponding the input layer and output layer and input layer, hidden layer, input layer, hidden layer, input layer? How can we represent all that? So I can find a solution for that. I can think 10 minutes for that, and I can pause that video. You can notice that. So now how can I represent all that weights? So we can represent all that weights by w. So w equals to the matrix or you can call array of array, multi-dimensional array equals to a matrix. A multi-dimensional array is called a matrix. So now we can give all that weights in that corresponding to I number column. This is column and this is row. So how many columns in that matrix? I number of I columns and number of j row. So how can we, what is I and what is j? So I is the input layer of that, so of that weights. So now I can take this weighted, this weights, all these weights. So for these weights, the input layer will be the input layer, means the in these weights are coming from something and take that value to something. So these weights are coming from input layer, so the input of that weights are input layer and output of that weights are hidden layer. So we can take this I and this is j. So I means the input layer of that weight and j equals to the output layer of that weight. So you can tell it in another way. The previous layer of outputs is called I and the next layer which can pass the value is the jth layer. So now for each connection to each node of that jth layer node is we can represent by w11, w12, w13 like that. This is first node, so w1 is, for that we need w1, and then this connection will goes to input layer number 1, so w11. This connection will goes to input layer number 2, so w12. 1 is corresponding to the output node and 2 is corresponding to the input node, and w13 is 1 is corresponding to the output node and 3 is input node. So here input node is 3, so these three weights are represented by w11, w12, w13. Then we can represent this node's connection, then w21, 2, 2, 2, 3. Okay, hope you understand what I can say. So now how can you represent all that weights? So we can randomly created a weights of that many output. Now you can see I into j. Here I means 3 because we can see 3 nodes are in input layer, so 3 into j means here 2, so 3 into 5, so we got 3 column and 2 rows. So let's see, is that matching? If that is match with that corresponding that structure, then we can wrote this is the equation of all weights. So like that, 1 2 3 we can get 3 from 3 output node, 3 input node, 1 output node, and from second out we get 3 more. So here how can we write that? So for sake of simplicity I can redrawing it. So now we can rewrite from that. Now you can we can write w. So w equals to w11, and w11 is this connection, the first one is getting from the first node of the output because the node of the output is 1, so 1, and then w12, then w11, and then w21. The first 2 is getting from the second output node, so from there and there you can see this connection and this connection. So we can write w11, w22, and then second we can then the first node 1 and second 2 is the second 2 is coming from the input second node, so w12, w22 like that. You can understand by watching and pausing the video. And the third will be w13 and w23. And now I can say you that I is corresponding to the column and j equals to corresponding to the row, and I equals to the input layer, j equals to the output layer of that weight. If the weight is that, then input layer is that and output layer is that. If we are calculating this weight, but we are not calculating this weight now, so the output will be this and this. Okay, so hope you understand. And now I equals to 3 and j equals to 2, and now we can see the number of column is 1 2 3 and number of row is 1 2 3, and we can get number of row and number of column, and we by that number is same, we can match that number. Now you can see for the second we also do the same and we get the same because 2 into 1, and we can like that this 1 1, okay, w21. So first one is that and second is 1, so 2 1 we get 2 column for this and 1 row for this. So you can see how can we mathematically represent the weights for all, for any. So what we can do in neural network, so in neural network we can first we can give each weight a computer generated random number. So now in that case what we can do is, just 1 minute, we can do is,
So, hello, one more time, we'll coming to the page. Why? So, I have to think, and I decide that I take matrix for each operation and each values, and that do some mathematical matrices operation, multiplication, addition, and try to get the all outputs. Now here I can see you. Here we can take a diagram. So why we take this diagram? We are making a library, but without visualizing. This is for visualizing the whole operation what we will doing here. This will help you to visualize, because without a standard model you can't visualize what will happening, and you can't make a mathematical formula to make a library. So for making a library you have to take a standard model, and as that model we create some formulas that will be applied for any type of model. Any, you can increase the nodes, the layer, any amount of your needs based on your needs. So we take this standard model, and by watching this model we try to make a mathematical formula, try to implement in code, and after math we get the mathematical formulas. By that we can do operation for any amount of layer and any amount of nodes. So here this is the input node, this is first input node. So input thing that user will send four input, x1, x2, x3, x4. This is the input data which will be fed into the input layer, and this data will be we getting from the user. So the data we need as a list. So we tell user that you have to pass all this input data as a list. So user will give me a list of input data, and that list is also a matrix. So this is the matrix 0 into 4. So don't misunderstand this 0 is be counting, we are counting from 0 in coding. So we give him 0, do not, but the 0 means one column. This is the column, this is the row. Okay, so 0 here we will here we will write 0th row. Column means one column, and fourth row, so 1 2 3 4, fourth row. Okay, so now, but we are not implementing this from, we are not counting this from 0, we are counting 1 2 3 4. So okay, so better understanding, this is 1 into 4, this is not 0, this is 1 into 5. Okay, so let's proceed. So now, so first we take in previous we will see that we take matrices for each weight operation. So these all weights will be a matrix. W1 equals to a matrix of W, which is corresponding to column, that column and that row, and for I equals to input layer, input layer of that weight operation or of that weights. For like for that weights, the input layer will be this input, and the output layer will be this, the hidden first layer. But for this operation, for the next weights, we have to take this is as the input, this is as the output, because we do not take input layer, we take the input of the connecting of the weights. So this is the connection input of the weights, and this is the output connection. So we take as the input connection, as the output connection, not as the input layer. For this third operation we take that this input as the input, and this is as the output layer. So I equals to input layer of W, J equals to output layer of W. W means weights operation. So what is the operation we'll taking here? So this is the first matrix, weight matrix of this all weights. Now W1, W2, W11, W12, W13, W14. So this column corresponding to this W11, the first one is coming for the first hidden layer node, and second one is coming for the second input layer node. So here this is W12 because this is 1 and this is 2. So 1 2, this is W13, this is W14, and like that this is also for the same node, this is also happening. So this is W21, this is W22, this is W23, this is W24. For third also happening same. For fourth, fifth, all the nodes, if there are many more nodes, then same will be again and again we are doing. So here we can make that matrices of all of this. We take all of these weights as a matrix and create a matrix which is column is I into J. So we are notating here. Why? Because we need a mathematical notation and mathematical formula. To create a mathematical formula, we need mathematical notation. So we do not use any kind of numbers. We use notation because making a library, we need mathematical formula. So here I equals to, for this weight operation, for each weight operation, I and J will be different. For this operation, I will be the input layer, J will be the first hidden layer. And for second, I will be the hidden second layer. And when we implementing all this in codes, we can see how can we implement all that. And now X will be a list of 0 1 into 4, mean 1 column 4 row, and B will be 1 into 5, means 1 column. This is the biases matrix we taking from that. So we can randomize all these value by np dot random dot random. By that we can this is a pre-built numpy library syntax who it's used for randomize any number of matrices. So we can randomize this matrix. By randomizing this matrix, we are randomizing each value of the weight operation. Okay, so we also doing the same for B, and X will be outed from the user. But be remember, for this operation the output will be x1 x2 x3 because this is coming from this nodes. But for this weight operation, the output will be the output of this first hidden layer. So the output will be y1 y2 y3 y4, mean this x1 into w11 plus B plus x2 w into y w12 plus x3 into w13 plus x4 into w14. All this goes to this, and this is the outcome of that operation, which is y1. And now we can use out y1 y2 y3 y4 as a x for this operation. For third operation, we use the outputs of these nodes of this layer. Each nodes have a output from their previous operation, so we use that as a x. Okay, so there, if there are many layer, more layers, so we can use same like that again and again. So now here, what is the h1? So the h1 will be the outcome of that operation before going to do a activation function. So x1 into w11 plus x2 into w12 plus x3 into w13 plus x4 into w14 plus the biases that will be already fed in that node equals to the h1. So you know this is the outcome before going to apply activation function. And after applying this activation function sigmoid, hope you familiar with activation function. You can use ReLU 10h based on your needs, based on your project what you need. And y1 will be the outcome for the node, first node. Same thing will be happen for h2 will be w21 w22 w23 w24 for each node of the first hidden layer will be same thing will be happening for second operations. And for the second layer will be happening same, but for the second weight operation, and also going on. So here the first operation will be outcome 5. We need this 5 outcome from each node corresponding to hidden layer, hidden first layer. So now how can I get y1 y2 y3 and y4 y5? So these 5 outcome are coming from the nodes of hidden first layer by operating all this operation. But how can I make a formula for that? Because we making a library, so for library we have to make a formula, because same thing will be applied for this operation, for this operation every time. So how can we make? Okay, let's think how can I. Okay, so here, after thinking a tons of ideas, I got one idea. So here we are need the outcome y1 y2 y3 y4 y5, but we do not need that. We need h1 h2 h3 h4, because we are after getting h1 we just apply the sigmoid function, activation function for each element, and we get the output. So here for the first operation, how we will get h1 h2 h3 h4 h5. So after trying and after trial error, you can, if you are with familiar with reinforcement learning, you are familiar with trial and error. So after I try doing the same thing, I can get an idea. If we multiply two matrices, w1 means weights matrices for the each weight operation, w1 for this weight operation, w2 then the w2 will be different, the I and j will be the different for the second operation, third operation will be changed, all these things, but the operation will be same. So we are just this is the standard models, this is the standard thing. We are visualizing this by this checking this model and making a mathematical formula to create a library. So now here I can see that if we multiply two matrices, the weight matrix with the input matrix, and add the biases matrix, then we get the H1, H2, H3. How wonder is this? I know, but this is not coincidence. I can create this, and you also can create this by trial and error. So here, how can I get this? So hope you familiar with matrix multiplication and addition. If you do not know, just go to YouTube and search linear algebra, then watch all these matrices. How can, if you do not know, familiar with them, then please pause the video and go, because if you do not know, you can't understand what I say, because here we are doing the operation of matrix multiplication. So first we are dot product. So cross and dot products are not same thing, so just not understand them. So just think that we are multiplying two matrices, w1 with dot product, w1 x1. If you familiar with matrices, you know what is dot product, what is cross product. So we are dot them, product them with dot. So now here how the operation will be held. So the operation will be held if only if one rule have, there have one rule. If the first matrix column will be same with the second matrix row will be same, then only we can able to apply those matrix multiplication, because the rule of two matrix multiplication is that the, but now I can see did we add this matrix b matrix. So now for this we have also a rule. The matrices of these two matrices, by dotting them we get a output matrix, and if the output matrix row will be same with that row, then we can only multiply the column with row of that row. So here I can see that by doing that, by multiplying these two matrix, we get result for each every pair. So for the first pair we get w1. How the matrix operation, the multiplication operation will be going on, you can see. If you do not familiar with that, just go, because you do not understand by saying. So you have to first familiar with matrices, matrices operation. So here w11 x1 plus w12 x2 plus w13 plus xm means the first matrices corresponding column to the corresponding row of first second matrix first row. So the first matrix first column, second matrix first row will be each element will be multiplied with each element and add with the second element. So here w11 into wx1 plus w12 into x2 plus w13 into x3 plus w14 into x4. That is the, I will get that this all terms, but we need one more term which is bias. So we can add them, and this is, we get 5 of this because we have 5 columns, so we get 5 output. Then we can see the biases row, and these rows are the same, so we can add those. This rule will be fulfilled, so we can add those, and by adding them we can get h1, the outcome of this this and this multiplication plus b1, outcome of this and this multiplication plus b2 b3 b. So at last we can get, by plus them we can get h1 h3 h4 and h5. So hope you understand what I say, and hope you understand my viewing angle, because I am, in one hand I am just focus the camera and one hand I just write. So please be adjust with that. I am not so, I know there are no excuses, but you have to understand. So w1 dot x1 plus b, by doing this we got this. If you do not understand how can I got this, just try to solve that by matrix dot multiplication, and add after multiplication the output will be add with the matrices biases matrix. Do yourself, you can understand. So we can get h1 h2 h4 h5 by multiply this and add this to second element, and after getting the output we can add the biases matrix, and we can, the result will be the output of this without apply activation function. Now if we can apply activation function, any activation function based on your need. If you need sigmoid function, so sigmoid or ReLU or tanh, we can apply the sigmoid function, and we can each element in with each element we can apply activation function, and we can get the y1 y2 y3 y4 y5. So now we can get the output of first operation, the first operation will be successfully applied. So now we have to save that, because for the second operation x will be changed, because for every operation x will be changed. Why x will be changed? Because for the first operation the input layer will be this and the input data will be from this layer, means x1 x2 x3. But for the second operation input j, I and j will be changed for every operation, because they are different for every operation. For the first operation this is the I, this is the j. For the second operation this is with the I, this is the j. So now we need the outcome, the input data coming from the first operation, and then we can add this as a replace this as a x. So now for the first operation we can take x, the input data as given by user, but for the second we need input data as a outcome of the first operation. So the first operation outcome is the second operation input, so we can replace that with that by saving that data. And we can in coding we can see how can we implement all this by some condition. We can say if the operation will be next, then we can change x and by with the outcome with the first operation, and again same thing will be happen. So for the third we have I and j, different I and j, and the outcome will be the second wait operation, outcome will be the input of the third operation, and then we can applying same thing. And so what we need to implement all this, we need three condition. For first condition we have to change I and j three time, because for the first operation the I will be the input layer and j will be the hidden layer. For the second operation I will be one hidden layer and j will be the next hidden layer, and for the third operation I will be the last hidden layer and j will be the final output layer. So three, we have to create three condition, and also we have in that three condition we have to change x for each operation. So now how can we implement all this code? Just let's see. And now you understand how can we. So the main mathematical formula we getting from all of this operation will be this, the first weight matrices of each operation. So this will be also different for each. For first operation w1 w equals to w1, mean this all weights. Second for this all weights. Third for this. Hope you understand what I say. So now this is the main mathematical formula. This is not a coincidence. We create this formula by trying and error. So by trying we get this mathematical formula, and for each operation the mathematical formula will be same, just x and ij will be changed. So we can implement in code by creating some condition. When the condition will be fulfilled, the I and x and ij will be changed for every operation, and by all things are same. So now this, by taking this standard model, we create a mathematical formulas that will be apply any amount of layer, any amount of nodes, and any kind of model. So this is the standard model to visualize all this operation, all this mathematical formula. Now we can apply this in coding. So let's proceed to implement all these codes. Hope you understand all. If you do not understand, this is because you do not know linear algebra, matrix multiplication, addition. If you do know, then, and if you do not understand with knowing the matrix multiplication, addition, then you can try yourself by open your notebook and try to multiply those matrix and add this matrix. You can understand probably. So now we can implement all this. So let's be proceed.